Hello there, you might seen my ESP32 based PCB drone in short films. Lot of subscribers asked for the tutorial, so here is the drone. As you can see, the frame of the drone is a PCB and that consists all the circuitry. It is based on ESP32 microcontroller and it has an NPU6050 gyroscope which will help to stabilize the drone. It uses 4 brushed DC motors to fly. Additionally, it comes with battery charging circuit and we can charge the drone using a Type-C USB cable. We can control the drone using our smartphones via Wi-Fi. This small drone has a range of up to 15 to 30 meters without any problem. Anyone can build this beginner-friendly inexpensive drone in below $15 or 1,500 rupees. I have worked several days to get better results, also did tons of iterations. So in this video, I will show you how I built this drone from scratch. Let's get started with this video. So after understanding the working principle of a quadcopter, I immediately tested it like this. I have made a simple frame using PCB and connected 4 motors. Surprisingly, I am able to lift the drone. But without a microcontroller and gyroscope, it is not possible to fly. So I added a ESP32 and a NPU6050 module. The NPU6050 can help to stabilize the drone. But after adding that, you can see it is not able to lift from ground because of the weight increase due to the extra modules. So to overcome this, either we need to increase the thrust of the motor or decrease the weight. Our goal is to build the cheapest drone so we can change the motors. So to decrease the weight, we can remove the separate modules and we can build a dedicated PCB for that. The dedicated PCB solves 2 issues. It will decrease the total weight and we can align the motors in perfect orientation and that will help to increase the stability. So I decided to build a custom PCB. This time I used ECDA Pro version to build the circuit diagram. ECDA Pro version is powerful than standard version and it is completely free. So here is the circuit, nothing new I added here. Here is the ESP32 microcontroller and I added the complementary components like the pull-up resistors for the ESP32. The NPU6050 is connected to the I2C pins of the ESP32. Then to upload the code to ESP32 and debugging, I added the CH340 USB to TTL circuit. To charge the battery, I added the TP4056 charging circuit here. Also to power the ESP32, we need to convert the 3.7 volt to 3.3 volt. For that, I added the MIC5219 regulator. To drive the 4 motors, I have added 4 MOSFETs. Here I added a voltage divider circuit for measuring the battery voltage. And that's it. After designing the circuit diagram, I converted the circuit diagram into a PCB. Here is the PCB. The outline is important here. All the 4 legs are symmetrical which will hold each motors. These 4 extra parts will act as the landing support for the motors. I placed the NPU6050 at the exact center of the PCB. Then I arranged all other components. After designing the PCB, our PCB looks like this. Now I downloaded the Gerber file for PCB fabrication. To fabricate the PCBs, I went to jlcpcb.com. I chose JLCPCB because of their low-cost, high-quality PCB services. You can get up to 6-layer PCBs for just $2. To order, click on Order Now and upload the Gerber file. After uploading, we can set the PCB parameters. Here I selected the standard 1.6 mm thickness and white color. Also I added the stencil for the drone because our drone has lot of SMD components. Then selected the address and shipping method and finally placed the order. After 10 days, I received the PCBs from JLCPCB. Here is the PCB and stencil. The PCB quality is awesome as always. Now let's grab all the components and let's start the soldering job. You can purchase all these parts as a kit from my site if you want. Check the description for that. The PCB assembly has 3 steps. Applying the solder paste using stencil is the first one. To hold the PCB properly, I designed and 3D printed a small jig. Now I placed the PCB in the jig and applied the solder paste neatly. Next is the assembly of the small SMD components. This is a very crucial step because of the misplacement of one component can cause total damage. After placing all the components, I placed the populated PCB on hot plate. I am using Miniware MHP50 mini hot plate. Now you can see the reflow soldering. After the reflow, our PCB looks like this. Now I separated the legs from the PCB. Now let's place the motors to the PCB. I am using this 720 type brushed motors for this. To properly mount the motors, I used this rubber grommets. So first I placed the rubber grommet on the PCB bracket, then I placed the 4 motors. Then I added the separated legs to the PCB like this. After placing all the motors, I connected the motors to the PCB. The final step is to adding the propellers. I have tested different shape, different size propellers, and I got good result with this 55 mm propellers. So I added the propellers to the motor like this. You have to care about the propeller direction. Please follow the article. Now about the battery, we can use 3.7 or 3.8 lithium polymer battery for this drone. But make sure the weight is very low and the discharge capacity should be minimum of 25 C. The discharge capacity is very crucial. If it is not enough, the drone will not work. So that's it. Our completed drone looks like this. Now let's connect the drone to the computer by pressing the boot button. To upload the code to ESP32, I am using ESP Launchpad here. First go to the ESP Launchpad and click on Connect. Then select the COM port. Now go to DIY and select the flash address to 0. Then select the file from your computer. Now click on Flash. It will take 30 seconds to flash the code. Then reset the drone. Then you can see the success message on the console. That's it. While charging the battery, the red LED light up. Blue will turn on when the battery is full. Now place the drone on a flat surface and turn on the drone. The drone will automatically calibrate. In the drone, there is 3 LEDs. The middle one will turn on if the battery is low or if any other sensor errors. The first one blinks while connecting to the application, and the third one will blink after connected to the Wi-Fi. You can download the application from the site. Now open the Wi-Fi menu and connect to the drone Wi-Fi. The default password is 12345678. Disconnect the phone from the internet and turn on location. Now open the app and click on the top right icon. Now you can see the connected message on your application. Now see the drone is responding with the controller. Okay, to manually adjust and calibrate, you can go to the settings menu and you can adjust the roll and pitch. Please refer my article for the proper tutorial. Now let's go outside and let's do some flight test. As you can see, it flies well. You need to adjust settings according to the drone to fly well, but you can master once you got the idea. You can buy all the parts and PCBs from my site. Circuit and code is also free to use. It was a wonderful experience to build this beautiful drone. You can try and enjoy this too by building one. If you have any questions, you can comment or you can use my socials to connect. Now we are working on height hold and camera support to this. If it works, you will get a new updation video. Stay tuned for that. So that's it for today. Hope you enjoyed and learned something new from my video. If so, please consider supporting me by liking, sharing and subscribing. It's all up to you. Thanks for watching. Bye bye.